In this video, we're going to be talking about the fundamentals of circles and a lot of circle vocabulary and a lot of rules and theorems pertaining to tangents. So we're going to define a circle as the set of all points in a plane that are equidistant from a given point called the center of the circle. So what that means is, and you don't need to write this down, this is your 10.1 notes handout that is attached to this video. If you would like to print it out, you certainly can, but you are not required to. So you could just be writing down the vocabulary in a notebook and then be using that to guide you. So here you would have a particular center, which I'm going to mark with this point, and then a segment, and we're going to have a name for that in just a minute. And basically, we would just keep repeating that length all the way around. I'm going to do the best I can here. And then when you connect all those points, there you get your circle. So this point in the middle is called the center, and there is a name for that distance. And the distance from the center to a point on the circle is called the radius of the circle. So we really kind of have a couple vocabulary words here. First, we have the term radius. So the radius is the unit that goes from the center to the edge of the circle. We have the center of the circle, which is just a point. Okay, and then I think everybody kind of knows what a circle is, but what we like to do in geometry is take the vocabulary that we know and then make it more complicated. It's just kind of what we do. Two circles are congruent if they have the same radius. So if you think of a small circle, here's a very small circle here on the bottom of my highlighter, and then here's a very large circle of my water glass. So you can kind of see the large circle at the bottom and the water moving around, but those are not congruent because radiuses are different. So they would have to have the exact same length for the radius to be congruent. There's another unit that we also talk about, and that is the diameter. So the distance across the circle through the center is the diameter of a circle. So what this looks like is we have diameter here, and we have a radius here. So what that means is if you have a circle and you're going from the center to the edge, that is a radius. I'm going to call that little r. If you have a circle and you have basically a radius and then another radius going straight across, that is a diameter. So this is a diameter here. I'm going to try to put in a little bracket and a D. So all the way across, all the way across, all the way to the other end is the diameter. You will notice there is a relationship between the radius and the diameter in that the diameter equals 2 times the radius. And that is something that we will use a lot. Furthermore, a radius is a segment whose endpoints are on the center of the circle and a point on the circle. So center to a point on the circle, and that's another way to define radius. And then we have some more vocabulary. A chord is a segment whose endpoints are points on the circle. So a chord will look like this. So here's your circle, and you have a point and then another point on the circle, and it's just connecting it. So a chord is a segment. A chord is a segment. A radius and a diameter are a segment. So remember, a segment has a definite beginning and end as you're going through. So you're going from a point to a point. So that is a chord. So a chord is a segment whose endpoints are points on the circle. Next, we have the diameter again. And now that we know what a chord is, a diameter is a special case of the chord because it's a chord that passes through the center of a circle. So if you look back up here at this diameter, and I'm just going to kind of go like that, this diameter is a chord because it's going from this point to that point across the circle. So a diameter is a chord. I'm going to highlight that. Diameter is a chord. that passes through the center of the circle. And we have a couple more vocab words. So far, everything that we've talked about so far are segments. So segments have definite endpoints. That is different than the next two terms. So a secant, and I know it looks like a weird word, but a secant is a line that intersects a circle in 2 points. So I'm going to kind of move this away, and we'll talk about tangent in a minute. But a secant is an extension of a chord. So here's a circle, and then you're going to just draw a line through the circle. And this is an example of a secant. A secant also could go right through the center. So another view would be something like this. Here's your center. That is still a secant. Okay, so those are images of a secant or diagrams of a secant. So a secant is a line. Secant is a line, and it intersects a circle in 2 points. All right, well, a line cannot intersect a circle in more than 2 points. So here are 2 points here, here are 2 points here, because otherwise it'd be doing like a curvy thing. So what can happen, though, is it can intersect the circle in exactly 1 point, and that's called a tangent. So a tangent intersects a circle in exactly 1 point. So here's your circle. The point would be on the circle, and then the tangent comes through like so. So this is an example of a tangent. And I like to say that the tangent touches the circle. Tangent is a touch. Tangent is a touch. Tangent is a line. Secant is a line. So a tangent is a touch, so it just touches it once. Tangent is a line that touches a circle in exactly 1 point. It intersects the circle in exactly 1 point, and a secant goes a second time. So secant, second time, so it goes through twice. I think it's really important for you to remember what's a line versus what's a segment. And the lines are secants and tangents, and the segments are radius, diameter, and chord. A diameter is a special case of a chord. I would encourage you to kind of talk through all that vocabulary to help you learn it better. All right, along those lines, let's go to our second page here, and we're going to look at example A here. And there's kind of this crazy diagram. So if you would like to write this all out, you could quickly pause the video and then write out what this sheet says. Otherwise, you printed it out. So I'll just pause for just a second for you to do that. Example A states, tell whether the line or segment is best described as a chord, a secant, a tangent, a diameter, or a radius of circle C. So here's our symbol for the circle. So they use what's a little circle with a dot in the middle for the point for the center, and then they name that center C based off the diagram. And then we need to go through all of our vocabulary. So remember, a chord, a diameter, and a radius are all segments. A secant is a line. A tangent is a line. A tangent is a touch. Tangent is a touch, and a secant is second time. So it goes through 2 times. So let's go through each one. So we have A is segment HC. Here is segment HC. It's starting at the edge of the circle to the center, and that is a radius. Letter B. We have line DG. Line DG. So right now we have a line, and it's touching the circle at just 1 point. So this is clearly going to be an example of a tangent. Tangent is a line that touches once. T for touch, just touches it once. We have segment BE. So we are only looking at B going all the way to E and stopping. and it's not going through the center. So this is going to be a segment that just starts and ends on the circle, and that's a chord. Next, we have line AF. Now this is tricky because we see segment AF, but we're talking about line AF. So they want you to assume that this would go on forever. So even though the line wasn't in the diagram, they want you to think of it that way. So this is line AF, so pretend it extends forever. So now it's a line and it's touching the circle in two spots. That is a secant. Okay, and then last but not least, I have segment BH, and this is a segment. It's starting at B on the circle, it's ending at H on the circle, but this one's a little bit different than BE because it actually passes through the center. So then this one would be our diameter. Okay, and now this question isn't listed here, but if HC was 5, that means BC would also be 5. And then the whole segment BH would be 10. So just a reminder that the diameter is twice the amount of the radius. All right, thanks, guys.